For those of you just joining us that were at the AP Lit test today, I would say go ahead and pause this video now and try numbers 5 and 6, giving yourselves 12 to 13 minutes of each. Then you can come back here and then check out the scoring guidelines for both. We ended up doing them just one after the other. And now they're going to grade, and we're going to go over questions. Let's grade both of them first. Only ask me questions on the actual grading aspect. We'll grade both first. Give yourself a number out of 9. Any questions on the grading aspect, whether or not something was worth a point, etc.? I'm going to go over to number 6 in just a second. Grading questions right now. Yeah.
So if you made a mistake in part A, with your derivative,
Yeah.
do you still count everything wrong for like part B, or do you get?
If you did it correctly for part B, no, you could still get those points. Just a little bit longer on this FRQ. I still see a couple of you guys still grading. Okay, real quick, anybody still grading? Okay, a little bit longer. Yeah.
So for let's
Uh-huh.
they simplify before they like plug in. If you simplify, then kind of get something like I mean I did.
You would get something different, or it would look different?
I mean I kind of got.
Uh-oh. Okay, hold on, let me check it out.
But
You got something different if you plugged in. You mean like the function? Is that what you mean?
like, well I said that 4 times ln of infinity minus ln of infinity is infinity, but that doesn't make sense. It should have been 0.
Where did it go weird? Because you said that you plugged in something differently, and so you got a different answer.
But okay, so before they did the ln rule, so down right there, I didn't do the next part. Down, yeah, I didn't do that.
So you did.
Just plugged in there, but then I said ln of infinity minus infinity is infinity.
Oh, it's indeterminate. So you could have gotten the point for, as long as you got this right, you would have gotten the antiderivative point, and then you would have gotten the limit expression if you actually wrote it as a limit.
Yeah.
But you would miss the answer point.
And do you have, so even after you take the antiderivative, you have to continue saying the limit as b approaches infinity?
Remember, you can't take away the limit until the b has been plugged in for. You can't erase the limit until the b has been plugged in for. Does that make sense? Carolyn?
So for letter G, if the test used is wrong, you can't get any points, even if you say it's converging.
What test did you use? Just curious.
Well, I was wrong, but because I just guessed.
Oh, so you said converging.
Yeah.
Well, with conditions, I'm assuming the conditions would be 1 point. Well, or the conditions could have been
Like, is it all or nothing?
reason to cross out point. Not all or nothing. I would have said, to be honest, I probably, like, if I was grading you, I would have given 1 point for converging, 1 point for a test properly applied, and I would have taken away one of those points if the conditions weren't there. That's what I would have done. So in that grading way, then you would have gotten 1 point for converging. I don't know if that's necessarily wise as far as thinking towards the AP. I would be careful, but yeah. You guys noticed, and I think this was also in the mock AP or maybe the additional practice AP, that the conditions are very important to state, right? Because I had to take away a lot of points for the conditions not being stated, and the same thing would be true here. So if you are using a test, you have to make sure that you state that the conditions are okay. Okay. But yeah, Caroline, with yours, I would have given you 1 out of 2.
So if you do,
But be careful.
if you say the conditions but get it wrong, you get a point?
The way that I graded for Caroline's just now is I said I would have given 1 point for converging, 1 point for correct application of a test. And I would have taken away a point if they didn't put the conditions for that test. So I don't know if you would have gotten a point for just the conditions. I mean, the correct application of a test, you would have had at least 1 point, even if you had made an incorrect conclusion from that test. Like if something had gone wrong, I would have said that still would have been a point. But just the conditions, I don't think that would have been worthy of a point.
Like if you did the test, but then you said it diverges, but like your conditions. And
But if your application of the test was okay, I would have given you 1. I would have given you 1. If something made it go wrong, or if your conclusion was wrong, then you wouldn't have gotten 2, obviously. But yeah, I would have said it would have gotten 1. Let's go in grade number 6. This looks a little bit like a Taylor series, and I think I see a little bit of an error bound down below, huh? Let's see how we did.
No, I did the question wrong.
How'd you do the question wrong?
I put 5 on the bottom of the last one.
5 on the, like you forgot the 4?
Now I'm looking at the letter D right now.
Oh. You put 5 instead of 5 factorial? No. You put, what did you do?
I just did something wrong.
Did you steal the wrong term, maybe?
I think I stole the wrong thing.
Because it's alternating, so they just took the n plus first term for the 4th.
Correct. I took the term from F, not G.
Oh. There you go. Keep an eye on which one's which. Lucy.
How do you know when it's like when you're doing like showing the alternating, but instead of just to the power of n plus 1? When it says general term is for a. Yeah, like -1 to the n plus 1.
Well, you could have technically done 2n minus 1. That would also be fine. Or even n minus 1. It depends on where your n would have started, though, right? Well, no, n minus 1 could have worked because it's just -1 to the power of. As long as whatever you put starting at n equals 0, because it's 0, then 1, then 2 based on the derivatives, as long as plugging into your expression would make it negative then positive, then negative then positive, you're fine. So it doesn't have to be n plus 1. But the problem is if you had it just to the n, because the derivatives kind of show me the n is 0, n is 1, n is 2, then I would need -1 to the 0, wouldn't be their true, but negative 1 to the 1, your signs would be opposite.
What if you did, oh, because I did negative 1 to the n, and then x to the n, and then minus 1.
Oh, x to the n minus 1?
On the, like, the n is just there, and then minus 1, not to the power. Yeah.
But that wouldn't, well, here's the struggle. Because the way that this one is set up, it's for like the derivatives n equals 0, n equals 1. So if that's the n's that you're using, negative 1 to the n, the signs would be off. If you were like, okay, I'm starting at n equals 1 instead, which is going to be awkward for your derivatives, but if you were doing that instead, the problem is 1 plus 1 would be 2 to be a positive, negative 1 to the 1, a negative 0, I guess that would be okay. But the problem is you would have negative 1 to the 1 times x to the n, 1 all over 1 minus 1. So you would have x minus 1, actually negative x minus 1, instead of 0 as your first term.
And did you have to show all, like, the first part of the thing, where it's like f of 0 on all the...
This just needs to be in here. It doesn't necessarily need to be stated separately. Yeah. Yeah. So when they ask you right here for, it's not so much that it's written all out, but that you can see they have the right double prime, right triple prime, right fourth prime. Did I answer both? Oh, Katrina.
For C,
Yeah.
it says plus 1, but aren't you starting at 0? Oh, no, you're not. You're starting at 1, huh?
You're starting at n equals 0. Up here, you're starting at n equals 0. Ultimately, I would put it this way. Ultimately, you're taking what you already figured out from above, right? You're plugging in t because you need these variables not to match. Kiddos, if you have x's in the bounds and x in the function, that's bad. Remember, FTC part 2 says a to x of f of t dt. Please follow that. But you're just plugging in from up here. So this one you're just starting with. And then when you integrate, you can actually not only integrate term by term, but you can integrate the general term too. Because the general term would say, hey, n plus 1 all over n plus 1. So you don't even have to really worry about the n's and where they start. Does that make sense?
Yeah.
So it's not so much that you're considering and like making up a whole new formula, you're just integrating the one up above. And technically on this one, n does start at 0, but the 0 is just 0, so they didn't write it because it was irrelevant. Does that make sense? So this is technically n equals 1. I think that's what you noticed. I think that's what you noticed.
Can you explain the comparative?
Yes, but let me peek at the question real fast. Oh, number 6, right? Okay. They're talking about the nth degree Taylor polynomial. Oh, hey, they give you a name for it. At x equals 1/2 around x equals 0. G is the function that you guys already wrote up here for C after integrating term by term f of t dt. Use the alternating series error bound. Okay, so remember alternating series. What do we know about alternating series? If I am doing the fourth, does it say fourth? Perfect. The fourth degree Taylor polynomial approximation. Remember, this is the approximation, the fourth degree one. This is the actual. This is talking about error in general, right? For alternating, I look at this n and I say a sub n plus 1. So then minus my g of 1/2. So actual, approximate minus actual is going to be less than. I would have taken a sub 5. Because of the fourth degree, n plus 1 is going to be the fifth term. And as you were looking at, or as you are looking at, letter, where'd you write the terms for this guy? For G? C, yeah. As you go down to the 4th degree, look at the 5th degree, not the 5th term in number, but the 4th degree stops here, go one more. So then you would steal the x to the 5th over 20. And as you steal the x to the 5th over 20 as your term, you plug in 1/2 to the 5th over 20, and then don't even simplify.
Where's the x to the 5th over 20
Yeah, I just circled it there.
Oh, you only did
Because this is my p sub 4. This is my 4th degree Taylor polynomial. So then take the next term, and then just state. That's good. All right, cool kids. I'll see you tomorrow. Wait. Pause. What's due tomorrow?
When you see
Oh.
Good. Have your when you see you think totally attempted, totally ready to go. We're going to go over questions, and then your forever and ever final on Friday.
for parts, if you recognize that this is FTC,